Okay, so we're going to talk now about inequalities in one triangle. So if you look at your notes, you will see that the first thing we have is the comparison property of inequality. Okay, remember that we had the equality property where we said if A equals B, then A plus C equals B plus C. Do you remember that property? Yeah, addition property. Okay, so this is going to be kind of the same thing, only this is the inequality. And basically what it states is that if A is equal to B plus C, and both B and C are greater than 0, then A is greater than B. Okay, which makes sense because if A, right, is equal to B plus C, then A has to be greater than both B and what? C, okay? And so that's the inequality property, yes? So that's what that property is stating. And that's not really a new property for us, but I'm not sure that we've actually looked at it written that way, okay? Now, how does that work for us with the triangles is what we need to talk about next, okay? So if we look at this one right here, we're going to talk about this corollary to the triangle exterior angle theorem, okay? So if you look at this triangle right here, okay, we've got several numbered angles, right? And what we want to know is why is the measure of angle 2, which is this one right here, greater than the measure of angle 3? Okay, and how can we tell that the measure of angle 2 is greater than the measure of angle 3? Okay, now if I take just this one right here, take this right here, triangle out, and I can say this is 3, right, and this is 4, and this is 2. Okay, now I also have this triangle here that goes like that. Do you see that? I'm going to make that one a different color so you can tell what we're looking at. Okay. Now, this triangle right here happens to be what kind of triangle? Isosceles, right? And so looking at the isosceles triangle, we know that the angle 1 is congruent to what? Angle 2. So we're going to use two different sentences to make this assessment, okay? The first thing I'm going to say is that the measure of angle 1 is going to be congruent or equal to, actually, if I'm saying measure, we need to say equal. So the measure of angle 1 is going to be equal to the measure of angle 2, based on what? Isosceles triangle theorem, right? If sides are congruent, then base angles are congruent, right? The second thing that I can tell you is that 1 is the exterior angle to the two remote interior angles 3 and 4. Can you see that? Yeah, okay. Well, based on the exterior angle theorem, that means that the measure of angle 1 is equal to the measure of what? Angle 3 plus what? Angle 4, okay? Now, since 2 is equal to 1 and 3 plus 4 is equal to 1, by substitution, what does that mean? Two equals 3 plus 4. Yeah, absolutely. So by substitution, I can state that the measure of angle 2 is going to be equal to the measure of angle 3 plus the measure of angle 4. Based on our inequality property, what does that mean about 2 and 3? Therefore, what? Therefore, 2 is greater than the measure of angle 3. Oops, that's a backwards angle. Yeah, what do you think? Now, this isn't a proof, right? This is a justify, just show, okay? So how is it that we showed, or how did we show that the measure of angle 2 was greater than the measure of angle 3? What did we use? Substitution. First, we used the isosceles triangle theorem, right? Then we used the exterior triangle theorem, right? Exterior angle theorem. Then we use substitution. Yeah? Questions? No? Okay, now we're using the same triangle, okay? And this time it wants us to explain why 5, this angle right here, is going to be greater than C. Why is 5 going to be greater than C? Yeah? Do you see anything that could show you that 5 was greater than C? If this is the larger triangle, okay, that's A and that's C, and this is 5. Do you see that? You take out segment BD. Do you see the larger triangle? Okay. So this is angle 3, and this one's not numbered, so we'll just call it angle C. Using the exterior angle theorem, what do we know about the relationship between 5 and C? The measure of angle 5 is going to be equal to the sum of the remote interior angles, which are what? The measure of angle 3 plus what? The measure of angle C. Okay? Now, using the inequality property, if 5 is equal to 3 plus C, then 5 has to be what? Greater than C, right? So the measure of angle 5 is greater than the measure of angle C. Now you guys, several of you asked me why in the beginning I put those little arc marks on my angle. Do you see now why? Sometimes it gets a little hairy if when we're doing inequalities and angles at the same time. Okay? Any questions on that? Okay. Let's move on to the next section. This theorem states that if two sides of a triangle are not congruent, then the larger angle lies opposite of the larger side. Okay? This is what this means, okay? The shorthand. The biggest angle is across from the longest side. Guess what? The smallest angle is across from the shortest side. Okay? That's exactly how that works. Yeah? All right. So let's look at it. Here's the town park, and it's a triangle. The landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Okay. Now watch. This is what I like to do when I'm given these questions. I number them. Okay. Now you have to pay attention if you're trying to go shortest to largest or largest to smallest, right? So we're looking for the largest angle, right? So do you want the largest angle to be 1 or 3? Okay. So I'll look at this and say, okay, this is the longest side, right? Okay. That's going to be the longest side, and it's going to be across from what? The largest angle. Okay. This is the next side, right? Going down. So it's going to be 2, and it's going to be across from what? The medium angle or the middle angle, right? This is the shortest side, so we're going to say that's 3, okay, because we said the longest was 1, right? And it's going to be across from what? The smallest angle, okay? For whatever reason, numbering them like that helps me a lot, okay? But be careful because you have to know if you're going largest to smallest or smallest to short or smallest to longest, right? Because if you get them backwards, then your answer will be backwards, okay? Now, we're looking for the largest angle. Which one is the largest angle? This one right here. So which two streets? MLK and what? Valley Road, okay? Now, the second question to this asks us what? Suppose now he wants to put a drinking fountain at the corner with the second largest angle, okay? Well, it turns out we went ahead and numbered that, so we know, right? Which one is going to be the second largest angle? It's going to be 2, so it's going to be the corner of what? MLK and is it Hollingsworth? Yeah? You think you could do that? Good deal. Okay. Now, we have one more problem or problem type that would be asked in this particular section, okay? This one is going to be ranking the sides based on the angles, okay? Remember that we said on the last page that the longest side is across from the largest angle, okay? Remember? Well, the largest angle is across from the longest side because it's the converse, right? So now we have to look at it and say, okay, how can we rank the sides from smallest to largest, see, shortest to longest, based on the angles, okay? So let's look at this particular triangle right here. We notice that it only gives us two angles. What's the first thing I need to do? First thing I need to do is find out what the missing angle is. So I'm going to say 180 minus 58 minus 62. And what is that missing angle going to be? What did you guys get? Did anybody get 60? Okay, so the missing angle is going to be 60. Now, I'm going to look at my question, and my question asks me to rank my angles or rank my sides from shortest to longest. Okay, so I'm going to do that based on the angle. I'm going to find the smallest angle. Okay, which one's the smallest angle? 58 degrees or U. It's going to be across from the shortest side, right? So I'm going to say that's one right there, right? What's the next angle moving up the scale? 60. Okay, it's going to be across from the next side, right? Getting a little bit longer each time. The third angle, 62, is going to be across from the longest side. Do you see that? Okay, now that I have them numbered, I'm going to go to my options and choose the one that actually has TV as the shortest, right? UV as the next angle, and UT as the longest angle, right? Which one is it? A. A is your correct answer. Okay, so we've got one practice problem for this section. Let's check it out. In the figure at the right, the measure of angle S is what? 24, so we'll fill that in. The measure of angle O is 130. So what is going to be the measure of angle X? Did anybody get 26? Okay, I got 26, okay? Now it's going to ask which side of triangle SOX is the shortest side, okay? Which one is going to be the shortest side? OX, okay? Now the next thing it says is explain your reasoning. So why? Why is OX the shortest side? Yeah, because it is across from what? The smallest angle, right? And that would be angle S. Yes? Okay. Let's look at the triangle inequality theorem. Is that the next practice problem you have? Okay. In the triangle inequality theorem, it states that the sum of any two sides of a triangle must be greater than the third side. Okay, think about that. The sum of any two sides must be greater than the third side. Okay, if they're not, then those three measurements are not a possible triangle. They will not make a triangle. Okay, so how do we check to see if the sum can actually make a triangle? Okay, nope, we're sides now. So we're going to add them. We're going to say 3 plus 7, okay, is greater than 8. Is that true? Yes, okay. Then I'm going to say 7 plus 8 is greater than 3. Is that true? Okay. 8 plus 3 is greater than 7. Is that true? Okay. Can this actually be a triangle then? The answer is yes. Okay. Let's try this triangle. 5 plus 10 is greater than 15. Is that true? No, that is not true. So what do I say? No. Only one of the statements has to be untrue in order for it not to form a triangle. Yes? So we're going to pause for just a second right here so that you guys can do A and B, and then we'll check our answers. Okay, so did you get the same answers that I got? Sorry, I guess you can't see them. Hold on. My mouse is not working for some reason. There you go. Let me ask again. Did you get the same answers that I got? Yes. Okay. So we know that 2 plus 6 is not greater than 9. So the first one cannot form a triangle. But the second one, those sides are actually in line. So we're good. Okay. All right. So now, last but not least in this section, we need to talk about what are the possible lengths. If you're only given two sides of the triangle, how can you find out what the possible lengths for the third side are? Okay, so it's going to work like this. Two sides of the triangle are 5 and 8. Okay, so we have 5 and 8 are our given sides. Okay, and we need to know what the third side is. So we're going to make the third side x. Okay, and we're not going to know exactly what it's going to be, but we know two things. X is going to have to be what? Less than 5 plus 8, right? So that means it's going to have to be less than what? 13. So we know it's going to have to be 13. And we know that x has got to be what? Greater than 0, right? Because measurements can't be 0. So the high end is going to be 13. But what is the possible low end that it could be? What you're going to do is you're going to say 5 plus x has to be what? Greater than 8. Okay? And then you're going to subtract 5, just like you would if it were a regular equality, and you'll say that x, therefore, has to be greater than what? X has to be greater than 3. Okay? Now, you're going to do the larger side here and the smaller side here, because let me show you what happens if you do it the other way. If I said 8 plus x has to be greater than 5, what will my answer be for x? It's going to have to be greater than what? Negative 3. Do you see that? Well, if it's got to be greater than 3, then it's already greater than negative 3, right? So you don't need that one. So this is going to be your range, 3 and 13. Now, watch how you write it as a compound equality. Do you remember how to do that? So I say x has to be greater than 3 and x has to be less than 13. If I write that with x in the middle, do you remember? We're going to say 3 is less than x, which is less than 13. Do you remember how to do that? Yeah. Okay. Just remember which side the alligator's eating, right? Okay. Okay. So let's try one more and then we'll pause for some practice. Okay. We have 4 and 7 for our possible lengths and x for our third side. Okay. So the first thing I know is that x has to be less than what? 4 plus 7. So that means x has to be less than what? 11. Okay. Then my next sentence or next statement that I'll make is that x plus what? 4. So we'll have 4 plus x has to be what? Greater than 7. Okay. So then if I subtract, I'll say x has to be therefore greater than what? 3. Okay. So what's my range for x? 3 and 11. Yeah? Finding the range. That's exactly what we're doing. It's finding the range. Okay, so we're going to stop here and we're going to do some practice on that one. Okay?